For section 1.1, we're going to have to remember how to solve equations and factor, so we're going to practice a little bit of that to begin with. In the first example, I have x terms on both sides of the equation, so I'm going to subtract 3x from both sides. That'll give me 2x minus 8 on the left, and then I'm just left with 12 on the right. Add 8 to both sides, and we get 2x equals 20. Divide by 2, and we get x equals 10. Number 2, we're going to distribute the 2 first, so we'll get 6x plus 2 equals 20. Subtract 2 from both sides. We get 6x equals 18, and divide by 6. So x equals 3. Number 3, this is a quadratic equation which will factor into two binomials. To get x squared in the front, that means I must have an x in the front of both binomials. Now I need two numbers that multiply to -6 and add to -5. So that would be -6 and +1. So I'm going to set up my factors as x minus 6 and x plus 1. Now both of those are being multiplied together and it equals 0. So that means one or both of them is actually equal to 0. So you take each factor and set each factor equal to 0, independent of each other. I'm going to add 6 to both sides of this one, and I'll get x equals 6. I will subtract 1 from both sides of this one, and I'll get x equals -1. So when you solve a quadratic, you should always come up with two answers. The key to that is a quadratic has a power of 2, so let that indicate for you that we will get two answers. Number 4, I have a 3x squared on the left and a 1x squared on the right. So I'm going to subtract 1x squared from both sides. Now I have 2x squared plus 5x plus 8 equals 4x plus 14. Subtract 4x from both sides. I'll get 2x squared plus x plus 8 equals 14. And then I'll subtract 14 from both sides. So every time you're faced with a quadratic, you need to get all the terms to one side. When you have the quadratic, that's when you factor it into two binomials. The front of the quadratic is 2x squared, so that means the front of one is 2x and the front of the other is x. Now I need two numbers that multiply to -6. So I could do 6 and 1, I could do 3 and 2. Well, it's going to be 3 and 2. And what I do is I put the 3 here and I put the 2 here. If I were to do it the other way, if I were to put a 2 there, that wouldn't make sense because then I have a 2 and a 2 in both terms of that factor. If that happens, I should be able to factor a 2 out. But if you look back at the quadratic, if I were to be able to factor a 2 out, then every term here would have a factor of 2 in it. So that's why I chose to put a 3 in the first term, in the first binomial, and a 2 in the second binomial. From there, I'm going to look at outer-inner. So the inner product is 3x, and the outer product is 4x. So 3x and 4x, do they somehow add or subtract to 1x? And they do. So if I had a positive 4x and a negative 3x, I would get positive x. So that takes care of factoring. Now, I like to draw a line, and I'm going to split them up. So 2x minus 3 equals 0, or x plus 2 equals 0. So I'm going to add 3, and I'm going to divide by 2. So one of my answers is 3/2. The other answer is -2. When we start working in geometry, and this will happen right away, You'll have to decide if both answers are good for our math problem, if only one answer is good for our math problem, or neither answers are good for our math problem. So you'll have to make that judgment call. I'll demonstrate some problems involving that. For now, though, we're going to look at the main topic of this section, and that is the notation of points, segments, rays, and lines. The points are always denoted with a capital letter, like this one here, A. Segments have an end to them, so they have like a start point and they have an end point. So you see a capital G marks this point and a capital O marks that point, and you would write segment GO or segment OG. Notice how there's little segment lines. I should say little segment markings above those letters. A ray is different than a segment. A ray has a starting point and it goes on forever in one direction. So that starting point is called an end point. You need to know that when you explain some of this to me. And then it passes through some other point. So you have to write the name of a ray starting with its end point, like here, ray AC. You cannot write ray CA because that is a different ray. That would be a ray starting at C and going forever, like to the left. So that's not what we have here. Lines go on forever in two directions. So we can name them with 2 points like we did the other items, or you can use a cursive lowercase letter to denote the name of a line. And the other good thing about a line is you could write line LW or you could write line WL, but notice how the line symbol is above the letters. Okay, I'm going to look at number 1. Name the segment in all ways possible. The endpoints of this segment are C and T. So you can write CT or you can write TC, but you have to use the endpoints to name the segment. Notice how I didn't use the letter A. Okay, number 2. The endpoint of the ray is F and it passes through E. So the only way to write this is ray FE. Make sure you put the ray symbol above the letters. Here's a line. I can name the line using the letters D and O with the line symbol above it. Or I could have done OD. Or I could pick 2 other letters. I could use D and G. So this could be line DG. This could be line GD. Or I could use 2 other letters, line OG and line GO. And there's one last option. There is a lowercase I labeling this. So you should write it in cursive form. We need to define the word congruence to do geometry. So congruent items in geometry have the same size. So if we're talking about segments, then they would have the same length. If we were talking about angles, then they would have the same measure. So we like to use the word measure when we talk about congruence, same measurement. Can 2 lines or 2 rays be congruent? Which is asking you, can they ever have the same measure? And the answer to that is no, because they don't have a measure. If they go on forever, we don't have a number to explain their length. Okay. Now we're going to start doing problems that actually involve some algebra as well as some geometry thinking. We are told that segment AB is congruent to segment CD. So you could look at a drawing. Here's a drawing of an AB segment, and here's a drawing of a CD segment, and I tried to make them look like they were the same length. So we're given that AB has a length of 3x minus 5. So they're using algebra to represent a length, and CD has a measure of 5x minus 13. Now, if the segments are supposed to be congruent, then these measures would be the same. By the way, when you have a drawing and you want to show congruence, you put a tick mark on the drawing. So I'm going to use like a single mark on segment AB, and I'm going to mark a single mark on CD, and that tells you visually that they're congruent. This is another way to tell you they're congruent. Since A, B, and CD have the same measure, that means 3x minus 5 equals 5x minus 13. Now I'm going to solve that for x. So subtract 3x from both sides. Negative 5 equals 2x minus 13, and then add 13 to both sides. And we get 8 equals 2x, so x is 4. Did we answer the question? Should we box that up? Actually, we should not box that up, because the question is asking for the measure of CD. So go back to the length of CD, which is 5x minus 13, and replace the x with a 4. So 5 times 4 minus 13 is 20 minus 13, which is 7. Number 6. PR is x squared minus 4x plus 16, and RO is x plus 26. Notice how I'm labeling the actual segments with the measures they're giving me. Then I know that the entire segment PO is 52. So by drawing it like this, hopefully you can tell that I need to add this algebra plus this algebra equals 52. So let's write that down. X squared minus 4x plus 16 added to x plus 26 equals 52. Now we have a quadratic equation, and the first thing we'll do is get everything to one side. I can also put negative 4x and positive 1x together. So I'm going to subtract 52 from both sides, and I will put those two terms together at the same time. So the x squared is just there, and then negative 4 plus positive 1 is negative 3, and 16 plus 26 is 42, minus 52 is going to be negative 10. Hope that's okay. I have a quadratic, so that will factor into two binomials. I need two numbers that multiply to negative 10 and add to negative 3. That would be negative 5 and positive 2. So I'm going to split those up. X minus 5 equals 0. So x equals 5. And x plus 2 equals 0, so x is negative 2. Now I have two possible answers for x, and they're asking me to find the length of PR. So what I need to do is I need to try both of them in for PR. Now PR was x squared minus 4x plus 16. So I'm going to put positive 5 in for x. So I get 5 squared minus 4 times 5 plus 16. And that ends up being 21. You can use your graphing calculator to calculate these. So 21 is an appropriate answer for the length of a segment, so that's a good answer. And now I'm going to do it again. PR is x squared minus 4x plus 16, and I'm going to substitute in the other answer I got, negative 2. When I do that, I'm going to put it in parentheses this time because it is a negative number. So minus 4 times negative 2 plus 16. I keep turning on the eraser. Yikes. 4 plus 8 plus 16 is what I'm getting, which is 28. So both answers are good answers. If they weren't a good answer, it would be like a 0 or a negative number. So that's how we know the X result wouldn't be a good answer. It wouldn't be a possible answer. We use the word possible. I might ask you, what are the possible values of X? I might ask you a question like that. We have segment DT. O is the midpoint of that segment. So that's the new information here. I'm going to use the eraser this time. It covered up some stuff. Ooh, that was fun. Okay. O is the midpoint. If O is the midpoint, that means DO is congruent to OT. See how I marked it with some tick marks? Is 3x minus 1. DT, DT, the whole thing, is 8x minus 22. Now what might be helpful is we label DO as 3x minus 1, and OT is the same length. So you could label OT as 3x minus 1 as well. Now you might be able to notice visually, you could do 3x minus 1 plus 3x minus 1 equals 8x minus 22, 3x minus 1 by 2, and set that equal to 8x minus 22. So there's options. They're the same difficulty. All right, I'm going to distribute the 2. 6x minus 2 equals 8x minus 22. I will subtract 6x from both sides, and I will get 2x minus 22. I will add 22 to both sides, so I'll get 20 equals 2x, and that means x equals 10. Did I answer the question? Nope. The question says find the length of OT. So OT is a 3x minus 1, so I'll replace x with 10, and I have to do 30 minus 1. So I'm getting 29 for the length of OT. The measures of 3 segments are given. If AB is congruent to DE, okay, so they're telling us this is a fact. AB is congruent to DE, and we are supposed to decide if this is true. So that's the question, if that's true. So we start with what we have as a fact. Since AB is congruent to DE, that means AB's measure, 6x minus 6, is equal to the measure of DE, which is 3x plus 18. So do that algebra. So I'm going to solve for x here and use that value for x. So 3x minus 6 equals 18. Add 6 to both sides. So I'll get 3x equals 24, which means x is 8. So go back to AB and check out its measure. So we have 6x minus 6 is the algebra. 6 times 8 minus 6 is 42. Okay, now check the length of RS. RS is x squared minus 3x plus 2. Pick up your 8 for x and replace x with 8 here. So 8 squared minus 3 times 8 plus 2. So I'm getting 64 minus 24 plus 2, which is also 42. So make sure you answer the question. Yes, AB is congruent to RS. Thank you.